Alright, welcome to a different video. And this is a series for question 5. We're looking at question C now. We On question C we're having a ketone right there. We're having a ketone. So now we're trying to react the ketone in the presence of this reagent that is there. And the name of this reagent is lithium aluminum hydride. And this is a reducing agent. So we're reducing the ketone to the aldehyde or the ket or the I mean we're reducing the ketone to the alcohol. And you know to say the positioning of the ketone that is right there. It tells to say the end product is going to be a secondary alcohol. Okay? So just like we did in the previous questions, we were given the alcohol and then we're trying to take that alcohol into the aldehyde or the ketone. We were oxidizing those alcohols to take them into the aldehyde or ketones. But the opposite of taking the ketones to the alcohols is what we're using, or what we're calling as reduction. And the reducing agents are very different from the oxidizing agent. So the reducing agent that we're using here is lithium aluminum hydride. That is what we're using here. So we know that our end product is going to be a secondary alcohol. So to put up that structure that we're going to have here is this one, two, three, and then we're going to have an alcohol there at position there. Okay, so you have a secondary alcohol. But the question is that how do you come up with a reaction mechanism? Take for instance, you're in the exam, then they tell you to show the reaction mechanism. They say, Tell us, how did you come up with this structure? How are you supposed to do that?" So that is the reason why we are here, trying to show the reaction mechanism. So the reaction mechanism for this one is very easy. You just break out what structure we've been given. That structure there. This is a ketone, right? And then what's the structure what that we're having there? We are having the structure which is the AI, that's aluminium, which is now bonded to how many hydrogens? It's bonded to 4 hydrogens. There's hydrogen there, there's hydrogen there, and also there's hydrogen there. And then one thing I want us to understand from here is that we are having aluminium which is positively charged. We know to say all atoms, all metals are positively charged. And then because we're having so much hydrogens that are here, we're having 4 hydrogens. This hydrogen there, there's that hydrogen there, that hydrogen there, and the hydrogen that is there. So it actually entails that this positivity here will be empowered. So instead of this being more, it's since this one is more positive, it tells you to say even if the hydrogens are positively charged, they are going to be negatively charged because the metal is more positive than they are. So we are going to have these be negatively charged. Okay. So since that is negatively charged, we're going to have an attack coming from the carbon. The carbon that is double bonded to the what? To the oxygen, which is positively charged. So now we're going to have that attack there. We're going to have attack which is coming from the carbon, attacking the what? Attacking this part there, which is positively charged, which is negatively charged. And our end product we're going to have is this. We're still going to maintain that structure. One there, two there, three there. Okay. Sorry. In fact, the attack is coming from there because this is what is more negative. So we're going to attack from here, going that side. Okay. So there's a bond there. That's not a double bond. The bond is there. So the attack is coming from the one that is more negative, attacking the one which is positive. And then after attacking there, we are going to have also the double bond that is here breaking. So join in there. So one here, two there, three there. So this has already broken, which is O there. Okay. So this becomes positively charged. Good. So connecting the rest of the structures. And then what we have there, we are having the oxygen because the oxygen has been taken there. I mean the hydrogen has been taken there. So we're having the hydrogen. That's what we have there. What's the next thing? The next thing that is going to happen is that we have got water in the compound, and this water is going to come and attack there. So there we have water there, and then we also have there. So the oxygen, which is negatively charged, is going to attack the proton or the hydrogen from the water, and these number of electrons will come there. So our end product comes as this is the final answer. In fact, it's going to be that, that, that. At this point, you know this is the oxygen, which is now bonding to the OH. So I've got OH right there. Then the rest of the structure will proceed. Good. There's also the hydrogen that is there, but it's okay. We don't want to show it. And you're able to see from here that the ketone now was reduced to the secondary alcohol. And after showing that reaction mechanism, we're having this product here. So one thing I should point out here is that the aluminium was bonded to how many hydrogens? The four hydrogens. In fact, we call that the hydride, aluminium hydride, because it is bonded to four hydrogens. So because the aluminium is positively charged, it's very positive. So it's going to make these hydrogens to be negative. This other hydrogen there negative, this other one there negative, negative, like that. And then the carbon here is positively charged. So it's going to attack and take one of the hydrogens that are on this structure there. And then we'll have forming that part. And then because there's an attack there, we are going to have the double bond to the oxygen breaking, and then when it breaks, we're going to have that structure right there. Then connecting, because there's water in the molecule there, we're still going to have the oxygen, which is negatively charged because it's reactive, it's negatively charged. It's going to pick the hydrogen from the water, and then we're having this structure, which is a secondary alcohol as our end product. So this is how the question proceeds. Let's go to question C. So in fact, we're going to question D. So D, we have been given this structure right there. There's oxygen there. Then there's that. Then there's Ag. Then there's NO3. There's silver nitrate there. Then there's ammonium hydroxide. In the presence of what? In the presence of what? They want us to predict the products that we're going to get. So what do we have on our side of the reactant? On the reactant, we can see that we have an aldehyde. Okay, that's what we're having there. Since we're having the aldehyde, one thing that we must understand here is that we're having the silver nitrate. And when you're having the silver nitrate, the first thing that must come to your mind is that we're trying to test for the presence of the aldehyde. And this test is called the Tollens test. We're trying to test for the presence of the what? Of the aldehyde. And we're calling this test as what? The Tollens test. We're testing for the presence we're testing for the presence of the aldehyde. There we go. We're testing for the presence of the aldehyde. So we want to show up the reaction mechanism. And when we show that reaction mechanism, and since we're testing for the presence of the aldehyde there, I want you to know that when the silver nitrate reacts in the presence of the aldehyde, to show to say the aldehyde was present there, we're going to have a carboxylic acid in the end. So after showing up the reaction mechanism, our end product that we must get from this reaction is this. We're still going to maintain our structure that they are connecting, they are connecting, they are connecting, and then the double bond will still go there, and then we're going to have that we need to get a carboxylic acid. And I'll repeat that again. I'll repeat that. No, I'll repeat that again. I'll repeat that. The silver nitrate is a test for the presence of the aldehyde, and that test is what we're calling the Tollens test. It is there to test it for the presence of the what? Of the aldehyde. And if the aldehyde is present, our end product is a carboxylic acid. And that is what we're having right there. But what is the general reaction mechanism? Let me show it. So the reaction mechanism is very easy. We are having the silver there. Okay, I'll do that, which is positively charged, and then we're having the nitrate, which is negatively charged. So our structure is this. That's OH. So what will happen? The first thing that is going to happen is that this structure is going to go undergo resonance to make it more suitable to react with the silver there. So it's going to undergo resonance. And when it undergoes resonance, we're going to have this structure. This number of electrons will come there. And then the hydrogen will still maintain. This becomes negatively charged. When it becomes negatively charged, it's very easy to react with any other substance or any other compound in the reaction, because the negative charge is saying that this is more reactive. It actually becomes more reactive when it has a negative charge. When it has a negative charge. So the Ag will come through. So this Ag will come through to pick a proton. Okay? So when it picks a proton there, we are going to have this. So remember what I was saying? This has become negative. The oxygen has become negatively charged, making it more suitable for a reaction because it becomes a lot more reactive in that state. So down there, we're still going to maintain our structure there. We're having this proton, that proton there, that proton there, that proton there, but one proton has been taken away, and we're having Ag, which has carried one proton or one electron. So after doing that, don't forget that we're also having the what? The hydrogen. So we must also remember that we are having the hydroxide in the present. We're having the hydroxide in the solution because this was reacting in the presence of ammonium hydroxide, and in the presence of ammonium hydroxide, we are having ammonia. When it splits, we're having an ammonia there, which is positively charged, and we're also having hydroxide OH, which is negatively charged. And this ammonia here, this hydroxide is very reactive because of the presence of the oxygen. It's negatively charged, and this is positively charged. So we're going to have an attack there. So when it attacks there, we're going to have this structure. Comes there, comes there, comes there, comes there. Still maintain. This is one, just two electrons there, the other electron there, then one electron here. Remember the other one was taken away. So we still have our hydrogen there. And then right here we have a bond. And that bond is the bond with the OH. Okay, we are having a bond with a OH connecting OH. So after this, we know that we are going to have an intramolecular reaction or a proton transfer. This oxygen here with its number of electrons are going to attack the hydrogen in the same structure. So we are going to have this attacking the what? Attacking the hydrogen. And this transfer here is called a proton transfer to stabilize that, or an intramolecular reaction. So after doing that, it goes down there to have that. This was the oxygen. It has now been attached to the what? To the hydrogen to form OH. That's what we have. And then we also have another OH which we got from there. And then this number of electrons will still remain there. They'll still on the carbon. The number of electrons will still remain on the carbon. So we're having the number of electrons there. And the Ag, or the silver that had carried one electron, will come and attack these electrons that were left by the hydrogen. And what will be going to be our end product? We're going to have our end product as we'll still maintain the same structure. There, 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 there. The OH is there. And then the other OH is what? The other OH is there. So after doing that, we are going to have the hydroxide that is in the reaction to come and attack this part right there, so that we can form uh, the hydroxide. Okay, so what will happen next here is that we are having the hydrogen here because we're having ammonia in the compound, and we're also having the what? The hydroxide. So this hydroxide is coming to take the what? It's coming to take the proton. And when it takes the proton, we're going to remain with the oxygen. Our structure, we have OH, and then this has been taken, and the number of electrons that are holding on to this will join that. So we're going to have 1, 2, 3, 4, 5, 6. This becomes that. So it now undergoes resonance structure, and that resonance structure we're talking about is a shift of these electrons from which point? From that point, coming where? Coming there to attack. And then we're going to have our end product as this. We're having OH there, and then this is going to form a double bond. Okay, so we are saying that this is a carboxylic acid. And this is a Tollens test. So remember, initially we had the aldehyde in the presence of silver nitrate and the ammonium as well as the water. We are trying to do a Tollens test. The moment you see the ammonium, the silver nitrate in the presence of an aldehyde, we're trying to test for the presence of the aldehyde in that compound. And when you have your carboxylic acid as your end product, just know that the Tollens test was positive. So if you want, you can write this structure in this way. This just becomes your final answer. You can write it that way. There, 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 there. You put a double bond right there, and then you put OH there. So this becomes the carboxylic acid, which is your final product. Carboxylic acid. And you're good to go. So this is how it works out. So in the next video, we'll still proceed to finish up E, F, G, and F. Still question 5. Thank you.